Crytek was happy to sponsor Global Game Jam in January of 2019. But in addition to our official sponsorship, a bunch of the Crytek employees here in the Frankfurt office decided to participate on their own. So they assembled into 4 teams and locked themselves into the office on a Friday night. They sat down with the given theme of what does home mean to you, and they put together 4 very different games in less than 48 hours. I thought these games would make great case studies, looking at how some of our own people grappled with game design challenges and put their creative minds to work. These were all built using CryEngine 5.5.2. So let's take a look at the game Homebound. So the first thing that you're going to see once we go into game mode is some logos, sort of intro credits here, and then we're right into the first scene. And of course we're in a cinematic which was created with track view. We're trying to establish that there's 2 environments here. There's this warm bar full of friendly people, and there's this kind of cold, dark world outside. So the second character that comes out of the bar is meant to be our player character. Technically, it's not really the player, it's a duplicate look-alike, because of course, during a cinematic, we don't want the player to have control over the player character. And this is a crucial moment right here where we see that little light in the window. It's going to be the only lit window we see in the entire game. That is our goal. So there's a little trick here. When the camera pans to the right and the player character is hidden, and instead we're being shown the target, during that moment, that fake player character is swapped out using flowgraph for the actual player character, which has been beamed off to a hidden part of the level previously. And at this point, the track view sequence ends, and now we have control over our player. Alex Klinger, who was the chief programmer on this project, decided that he wanted to use a USB game controller, the Xbox controller, because it provided a lot more control over the player than just the WASD keys. And so I'm using the controller here to navigate. First, I tried going left and kind of quickly ran into some obstacles. So right away, you're going to get a sense of the world that they created here. They decided, given the short time frame, that they wanted to leverage as much of what the engine could sort of give you right out of the box without having to do a lot of development work. This is Matthias Otto, aka Mato, who was our level designer and was responsible for most of the layout and kind of snapping together all of the pieces.
There's a lot of things for free because we have the clouds, we have time of day, we have lights and fog and shadow that work out of the box very good.
The first thing that you see that's real gameplay, this game mechanic, is the difficulty of trying to cross the street with this constant flow of unpredictable traffic. So you see what my first attempt was, that I died, I got hit by a vehicle, and I got snapped back to a predefined point earlier before I actually crossed the street. You'll also notice some non-player characters that are sort of wandering around in little activity loops. And you may also notice, if you've done this sort of thing before, that the camera is moving in kind of a side-scroller way, but not strictly side-scroller. You'll see an event, which is as we pass a certain point, there's an invisible area trigger, which triggers that police car to go flying by. We don't know why yet. When we get to this accident scene, we come across our first sort of detour. The game designers kind of quickly realized that just traveling in a straight line to that goal that we saw is not so interesting, and so they built in this nice accident scene. I'm also using this scene to try and show you some of the ways that they solve the problem of guiding the player through the level. So what I'm doing is trying to move my cursor further to the right, and now sort of towards the back and past this police car. And you see 2 things happening. One is I'd simply get stopped. I can't go any further. There are these invisible barriers that they built, which is sort of a quick and dirty, if not super elegant way to solve the problem of keeping the player from going where they shouldn't go. This is Alex Klinger.
We need to somehow tell the player to not walk somewhere. But we still have physical objects which move that way, right? Like we have the people walking, we have the cars coming, and we don't want that they get stopped by a box collide or something, right? Because if I just would place a glider here, which is like everything would collide with it. So what I did, I wrote a quick component in C++, which is called player wall.
It just blocks the player.
It's literally that. So,
but there's no visual clue. They would just kind of run into a glass wall.
Exactly.
Another one of my favorite details about this scene, I don't know if you'll notice, is that the streetlight there is actually swinging in the wind. And I'll have Matto show you in detail the flow graph to create that effect. It's not actually being moved by the wind, it's just a tricky little bit of math. And now we start to wander in one of the most interesting parts of the game and see our second game mechanic, which is these dogs. Obviously kept very simple, low poly, just a box on sort of a rope. But together with the sound and just the darkness and the atmosphere, kind of goes a long ways in creating this nice little game mechanic. Now that we've been sort of introduced without too much of a challenge to the idea of the dog, now we have our first sort of pinch point that level designer Matthias Otto designed very carefully so that you can just squeeze by that dog and you can count on it getting itself wrapped around the trash can because it starts lunging at you when you're sort of off to the left. The key game mechanic here is crossing these lanes of traffic. They're going to get more and more difficult as we go. So one of the first things that had to be done is Jean-Baptiste Hervé, and I hope I'm not butchering his name too much with my bad French, designed an entire self-driving car system. I told him he should go out to Google and apply for a job there if this game development thing doesn't work out. He had to come up with ways to spawn and move the vehicles unpredictably, but also make them avoid colliding with each other and colliding with anything except the player. So I'm going to go into detail on how he did that. You may have noticed that I also tried to go to the left back there after I crossed the street and ran into some more carefully placed obstacles. And now we're being guided by these fences to get into one of the most scary parts of the game, which is a large graveyard scene with very little light. All of the darkness really comes into play here, along with the rain, the lightning, and carefully placed fog volumes. Here we have a couple of dogs that we have to sort of dodge, and we start to get into the gravestones, which are really illuminated with the flashes of lightning. You hear the church bell go off as we enter an invisible area trigger here. There's more than one path that we can take to get through these various gravestones. And one of the most interesting parts of the scene design here is an actual funeral going on. Unfortunately, somebody picked a terrible day to be buried in the rain and the dark. Level designer Matthias Otto, who we affectionately call Matto, didn't use the global fog, he used fog volumes.
To also make sure that the view to the objective is not blocked, because using global fog would make the view to the final building, you wouldn't see it. So that's why I placed many of these fog volumes. They look absolutely gorgeous.
Matto also pointed out the density, noise, time frequency, and density noise frequency properties that I'm changing here on the fog volumes. He used these to animate each of them individually. So you may sense here that now we're into a more difficult part of the game, and I'm also demonstrating by trying to move my joystick to the right the more subtle cue that I was talking about in terms of guiding the player through the game. The camera simply refuses to go where it doesn't want the player to go. The intention was actually that Victor would go through the game and do a camera pass and tweak that spline in the end, but they ended up running out of time. So what you're looking at is kind of a rough draft of what they consider to be the ideal camera path. So this is our most challenging street crossing, and the thing that, in addition to the 4 lanes and the higher density of traffic that makes it tough, is that cluster of nervous AIs there in the middle sort of blocking your way. So at this point, we're actually past all of the obstacles. There's nothing left to do but sort of cruise forward. And to create this sort of mood change in the game, you're going to start to hear this final music that gives us a sense that we're finally coming home. And now we start to get a good look at the window where we're headed. The fact that this is the only lit window, the only source of warmth in the whole game, since the bar really kind of attracts us naturally. There's also a subtle thing I'll point out here, which is that the camera's not pointing right or left, so you can get the sense that you don't have any cars to fear at this point. And now a track view sequence seamlessly takes over, and the camera just glides up, so we get the sense that the player is going up the stairs because the lights switch on. And as the camera tracks around to the right of the building, we get a look inside the player's apartment. The light comes on in the player's house, and we see my favorite detail, which is the cat. Happy to see you. So that's the walkthrough of the game. Pretty straightforward, but that's a lot to have accomplished, I think, in 48 hours. So let's take a look at how it was built. After the team came up with the concept, they broke apart individually to begin work. Victor Ikes mostly worked on art and modeling. Matthias Otto worked on the level design. Alex Klinger did most of the programming. And where I'm going to begin is with the cars, which form the chief game mechanic. Programmer Jean-Baptiste Hervé was tasked with coming up with a way to spawn and move the cars and to keep them from colliding with each other. Victor Icase modeled a nice variety of trucks and cars. You can drag them right from the assets folder into the level, and what I've done is create a little asset zoo and dragged an example of each one of those here. He also created a variety of simple, solid color materials for them, and I've included an example of each one of them here in this asset zoo. What the programmers did was create code to spawn the cars, to move them, and to avoid collisions. So I'm just working with a new level here. I've done a little bit of sculpting of the terrain, and I've made it dark, but that's all I've done. And what I'm going to do is actually set up the car system just as they did in the final game. If you look at the schematic editor, you'll notice that the cars themselves are schematic entities, and they consist of these components. Most of these are going to be familiar. There's a mesh, of course, and that's actually going to get randomly replaced from one of these meshes here that Victor modeled. There are lights for the headlights down here. There's, of course, a rigid body. There's a plane constraint because these cars are not meant to move on the z-axis. They don't move up and down. There's a trigger. And then there are two custom components that the programmers created. One is simply called damage. This is Alex Klinger.
So most of the objects in the scene which kill you are just physical objects. I think all of them are just physical objects. So the only logic we really need to check here is if we collided, with what did we collide? And in our specific case, we checked if the object we collide with had a damage component. And the damage component just defines the object to be lethal to the player. So the player will check for a damage component. And if there's a damage component, he just dies.
Then the car component has a move speed, a maximum velocity, and it has this fail-safe, which is called max lifetime, which I'll talk about in a second. So let's just show how simple it is, based on what they made, to get these cars moving. What I'm going to do is begin by creating an empty entity, and this is where I'm going to spawn my vehicle. I'm going to make my vehicle drive right to left. This system is very simple. It's just set up to drive cars in a straight line. I'm going to name this thing car spawn 01, and I'm going to attach a component to it, and that's going to be my car spawner. And the things that we care about are the min delay and max delay here. We're not going to do anything with translation, rotation, and scaling, but this is going to determine what kind of time interval it randomizes between this shortest possible time and this longest possible time. Then I want to create a kind of a destination point. I'm going to drive from here to here. So I'm going to make another empty entity over on the left. Just for clarity's sake, I'm going to call that car target 01. One thing that the programmers did was expect that you would link the destination to the spawn point. They're assuming that you've done that correctly, so there's no sort of tricky code to confirm that you've done that or point it out if you haven't. So all I'm going to do is select my spawn point, click on the entity link picker, and click on my target, and then I'm going to get a straight line. In my case, I got a little bit carried away with the terrain, and my link line is buried underground, so I'm actually going to move things up a bit until I can see the line. So now the cars should be able to move straight across. By the way, the vehicles are very, very simple if you look closely at them, including that the wheels are not spinning. This doesn't in any way use the CryEngine vehicle system. They're just basically boxes with lights. Now what I need to do is create a little flow graph. I already have one created here, so I'm going to go ahead and add it to that and go back here to my main flow graph, and here's my car spawn entity right there. And on game start, I need to get the ID of the graph entity, which is my spawn point. And if you look under the game folder in the flow graph nodes here, you'll see a custom flow graph node called activate car spawner. And it literally just spawns a car at the position of this ID, this entity right here. So when the game starts, go ahead and activate this thing. One other thing I need to do is change the state to 1 to tell it that I'm interested in actually spawning it. And that's it. That's the entirety of what it takes to get this working. I'm going to save, go to full screen view, hit Control-G to play, and within some time interval between my min and my max time, the cars are going to begin spawning. And you'll notice that the vehicles are randomized from all of that selection of vehicles you see back there in the asset zoo, and they're also randomized in the color. So that's all there is to using this system. The code makes it super, super simple. Drive in a straight line from point A to point B and avoid colliding with each other. Now, so you can see it in its full glory, I'm going to go down to this little valley that I created, and I've built a couple of intersections that have overlapping lanes. And I'm going to show you what happens when I've got 2 lanes of traffic going in opposite directions here and 2 lanes of traffic going in opposite directions here, and the cars start getting into position where they're going to collide. So in a few seconds here, you'll see the vehicles start to spawn, get the nice headlight effect, and it's going to get more and more dense. And sooner or later, they're going to get into a position where they're going to risk running into each other. This is Jean-Baptiste Hervé, who created the car movement system and also the car avoidance.
As you may notice, on a crossroad, cars just stop in order to avoid each other.
But what's challenging about this is the cars that are going exactly towards each other in completely opposite directions don't need to avoid each other because they're in parallel lanes. But cars that stop right in front of one in the same lane do need to be avoided, and cars that are coming perpendicular need to be avoided. So there's a very sort of specific criteria that needs to be considered in order to make this work. What Jean-Baptiste did to solve this is a little bit of calculus, and that's this line here, 148. Uses what's called a scalar calculation to look at the exact angle on the raycast.
What we did is we used 3 raycasts.
It's raycasting straight ahead and slightly off to either side and looking for vehicles at a very specific angle. The one thing that he didn't do is deal with braking and realistic deceleration. That obviously would have been a lot more complex. So as Jean-Baptiste says,
cars in this world have really good brakes, but I think it's fine.
They literally stop immediately. What you're going to see is a little green and red line. This is actually created just for debugging purposes, and I'll show it to you in the code. I remove the comment on it so that you can actually see how the collision avoidance system is thinking. You've basically written the self-driving car future here.
I wish
Nobody dies.
Yeah, if in the future cars have super brakes and you only need to go in one direction, you can use my system. It's fine. But otherwise, I won't recommend it.
Jean-Baptiste had to make some decisions, and he had limited time to perfect this system.
My test was basically creating a huge crossroad, and I went for a lunch break, and when I came back, everything was freezed, and it was perfect. In order to avoid any issue, we have this maximal lifetime attribute. It's another delay, and when we reach the end of the delay, we just destroy the car, basically. That's why you don't see the car after being hit. It's because, maybe the car that hit you went into a wall and it was blocked by the wall or the house or anything, but by the time you come back, it was just despawned by this piece of code. It's really clumsy. I won't use it in a real game, but in our case, it did the trick.
If we take a look in the actual game, you'll see these red boxes. These are custom area triggers that Alex Klinger wrote, and all they do is listen for the player to enter and to leave them. You'll actually see that he's sending messages to the console, alerting you to exactly that. So that's this player trigger 9 in this particular intersection. And if we go back and look at this main flowgraph script right here, you'll see how Mato actually implemented this in the game. So here's the player trigger, and it has 2 events, enter and leave. And what Mato did is feed the enter event to the true side of a Boolean and the leave event to the false side. And that output, true or false, feeds this state input. Jean-Baptiste, who actually wrote this node, explains how it works.
We increment the delays. We have this internal counter, and then we compare, which is set to the random bound we chose previously between 2 and 10. And when the amount of time spent is 0 or negative, we can spawn a car. And we set, obviously, after spawning the car, we set another delay, which is random between the lower bound and the higher bound.
Once he started testing this car game mechanic, Mato quickly realized that he was going to need to vary the timing on how often the cars spawned. But he also realized that since the camera was very specific and not under the player's control, that he needed to come up with a sort of a rule in the name of fairness.
One rule in terms of gameplay is the cars that drive into the camera, they are way more random than the ones that come from the back of the camera. They are very timed.
If we go down here and look at where cars spawn at the end of this road in this left lane and look at the properties of this car spawner point here, you'll see that he uses a wide range from 2 to 10 seconds. So it's quite random and unpredictable. But if we go to the other end, which is behind the camera and the player can't see him coming from this direction, and we grab this spawner here, you're going to see that they're very predictable. It's going to be every 8 seconds. I'm going to go over here where I have 4 lanes of traffic going in either direction. I'm going to select all of my spawn points here, And I'm going to change this range of times to be much closer together. So we're going to get into much more significant traffic jams here, as if having 8 lanes of traffic wasn't already enough. If I go back to those same spawn points and make this much more expansive, let's say between 2 and 12 seconds, my traffic pattern is going to be a lot less dense. Although 8 lanes are still going to pile up sooner or later.
When we spawn a car, the previous car is not that close from the spawner, like as we said previously, in order to avoid car being spawned on the top of each other. So then we basically spawn the entity in order to make the car driving forward and not on the left or on the right. We rotate the car in order to face its destination.
And we call these two functions getRandomMesh and getRandomMaterial. And they do just what you would expect them to do. If we go up here and look a little bit higher. So first we need to get a car model, and this is literally randomly selected from this project folder. And those are the vehicles that I just showed you in the asset zoo, and it just filters them out by extension name, so it's just looking for CGF models. Same thing with the material. It randomly selects MTL files, material files from that same folder. And again, these are just simple, solid colors.
We verified everything went okay during creating getting the mesh and the material and stuff. We set the destination to the car, which is where she should go, and then we store this car's position in order to, when we spawn another car, we can compare it in order to avoid car being spawned on each other. Now, if we go into the car component, on every frame we saved our destination. The destination is the position that the spawner gave to the car component on creation. So if we are close enough, we just stop to update the car and start to destroy it.
If we look at the car spawner CPP file on line 47, it again assumes that the level designer correctly linked a destination entity to the spawn point. It gets that identity there and it passes it on as the destination. The second major game mechanic and obstacle in the game are the dogs. These are all created as prefabs, and we'll take them apart piece by piece here. The first one here is just now going to appear to kind of teach you about how it works. As long as you stay on this side of the fence, which you kind of have no choice about, there's no danger that you're actually going to get killed, so it's sort of a gentle introduction, and you see how the dog behaves. It lunges at you as long as you're within a certain radius. The dog itself is nothing more than a box attached to a bunch of cylinders, which is tied to a stake, and they're all constrained so they can rotate around each other. Now that we've been introduced to it, then we get to actually try and steer clear of one that has actual danger of killing us if we get too close. Otto is very clever about positioning the trash can. Since the dog is always going to start lunging at you once you reach into its radius over here, it's always going to lunge towards you, which means it's going to get its chain wrapped around the trash can, which means that you can actually slip by here, but it still feels threatening. So let's stop and take a look at how this works. The first thing I'm going to do is actually brighten up the level so we can get a better look at what's happening. So I'm just going to change the time of day so we can have a clearer sense of what's going on. And I'm also going to turn off the rain temporarily. And if we select this dog, we're going to see right away that it's a prefab. What I'm going to do is actually open up this prefab over here in my property so that we can see all the pieces of it. And you see that each chain segment is a separate cylinder. We have the box, which is the dog itself. We have the stake that it's tied to. And what's interesting is if you pull back, you're also going to see something in the prefab called radius and radius 2. Mato was trying to design the level very precisely so that the dogs were as threatening as possible, but that you were still able to get around them. And basically he needed to figure out what the radius of the dog's movement was when it was fully extended to the length of its chain. And he realized at some point the easiest way to do that was to simply use a cylinder so that he could see this circular radius and plan the minimum and maximum radius. If the player was in there, the dog would lunge. So if you look in one of these dog prefabs at these two radius objects, they're buried in the ground, and he just used them to give himself a way to easily visualize the minimum and maximum range within which the dog should react to the player. What's interesting is if you go into the prefab itself in FlowGraph and look at these two objects, all they do when the game starts is beam themselves to 0, 0, 0 in the level so that he has the best of both worlds. They're always there for design purposes, but they don't interfere with the game. Now let's take a look at the actual flow graph that makes the dogs move. This section right here is actually building the links of the chain and assigning constraints in there so that each cylinder rotates around the endpoint of the previous cylinder. It just does it dynamically on game start rather than assigning constraints to the entities. And up here is the script that actually detects whether the player entity is within this range that he's defined between 5 and 10 meters. There's a little bit of a randomized delay before the dog reacts. We generate a little bit of randomness to add to the lunging. And then the thing that actually makes it move is you'd probably expect to be a physics action impulse, but he used what's called physics params velocity, which avoids the problem of constant acceleration every time we provide an action impulse. And this thing will continue resetting itself after this delay. It also, of course, triggers the barking sound that Lucas Kyle designed. And that's basically all there is to the dogs. In terms of the city itself, CryDesigner was used to create the layout of the city streets by using modular sidewalks and streets that you can see here. If you actually peek under them, you'll see that they're floating over the terrain height map, I think about half a meter above it. Designer was also used to quickly create these simple building placeholder boxes and save those as prefabs. That allowed Mato to work on designing the level and populating it with the building prefabs, while Victor modeled the building details. Those details included these windows, the gutters, the steps, the floors, and the roofs. Although it might be a fairly obvious strategy to construct the buildings in a modular way using prefabs, Victor did something else that I thought wasn't so obvious and which saved him a lot of work. He made them vertically modular, so you can take any tall building and simply move any number of floors and hide them underground to turn it into a shorter building. So that made it super easy for Mato to create a variety of building heights, even though this whole level design is obviously very gridded and regular. There are even high-rise buildings made by simply stacking multiple building prefabs on top of each other. Prefabs were also used to create the streetlights, the fences, cemetery elements, and the dogs. Once Victor modified the prefabs by adding those detailed CGFs, all Mato had to do was update his prefab library, and the entire city was updated at once without having to redo his level design. Let's take a look at the camera system and the way that the player is guided through the level. The secret to this is track view splines. If you open up your track view tool, go to File Open, and I'm going to open up Camera Player Follow. And if we start back at the bar where the whole game begins, you're going to see that there are two paths here. This one to the right is for the camera, and this one here is the suggested path, or the sort of ideal path that the player must follow. So what happens in the code is that every frame of the game, wherever the player happens to be, the code finds the nearest time marker on this particular path. So that's how the camera stays in sync with the player's position, but the player is still free to move around. I'm going to let Alex explain this code in greater detail.
So as you can see here, we have a track view sequence which goes through the whole level in order to have this following logic for the camera. And the only part we were missing was one flow graph node to determine on which second of this track are we from the position, right? The player can move around, and this track is technically just from start to end on like a time scale. So we need a conversion node which can convert a position on this track to a time on the track.
Since that time marker has a parallel on the camera path over here, it goes and looks at the camera path and says, okay, that's where the camera should be, and tells it to actually move the camera to that position with a little bit of dither, a little bit of a delay.
We already had a node internally, which we just used for the specific case. So what it does, it just looks at the track view data and sort of does a conversion from the position inside the scene to the closest time on the track view. And that's pretty much like what most of this code is for. So for example, this movie sampling flow node helper is just a helper class to do the whole sampling of our track view sequence. And then the movie get time from position is actually the node we want to have inside the editor. And as you can see, it has a sequence, a node, so you can set up which sequence you want to listen to, and you can set up what's the target position and the target entity, and it returns you the time and the position and so on, right? That's just the configuration of the node. The next part is just processing events for this node, and inside here we just, like if we start, we clear the cache, which is just used in order to like store information which we need while like processing the data. And in the activate, we use our helper functionality to convert positions to time. And that's pretty much what this whole node does. It gives a good sort of idea how you could process the track view data from the engine for whatever purpose in your game, right? It's a good view, but it's also already like a little bit more advanced. But the whole concept here was just to get the time from a position.
So, the swinging streetlight. I created a prefab. I wanted to use this way more often originally, but it turned out to be just used once. So, let's look at the setup. Let's open the prefab and go to the flow graph. So, in here, we have a very special node, the physics param simulation node. It sets the entity's sleep speed to 0, and the reason why we do this here is the sleep speed is currently not exposed on the rigid body itself, so we have to manipulate it later on in flow graph. If you set the sleep speed to 0, you essentially say to the physics simulation that it should never stop simulating. Usually you have sleep speed of 0.04 or something like this. It means when the object moves below 0.04 meters per second or something like this, then it will start resting and it will only ever start awaken and continue the simulation when there's some force going on. So in the game SDK, we have a rigid body X entity, and with that entity, all of these properties are exposed. It's not yet there on the rigid body component. Maybe at some point we get a rigid body property component and then we can tweak all the properties. But I guess this is just for ease of use. It's not everything is exposed.
I'm assuming that it's pulled apart. First of all, it's legacy, it's game SDK, and second of all, with Schematyc, with entity components, everything's completely modular. So all those things that you're talking about could be added if you add components like the AI and the health components, that kind of stuff. All those properties are via specific components to keep everything as modular as possible. So instead of having a giant inflated rigid body X, you can build a custom one that just has the properties you need. Is that right?
Exactly, yeah, exactly. So I'm getting the entity position and I'm starting a auto 3D noise. Now this is, I love this node. What this node essentially does, it gives you a fluctuating vector in the range of the amplitude with a frequency. So the higher the frequency, the more shaky it is. The vector will be something between -1 and +1, and it will never like jump from -1 to 1 instantly. It will always smooth. Let's turn on the debugger, and actually we can see right away what this node provides us. Every frame, it will continue to randomize this vector, but again, it's not like a random vector. Like it wouldn't generate random values. It's moving. It's a moving point.
It interpolates smoothly from point to point.
Exactly.
Between its values.
Essentially, it moves a point in a given space, which is defined by the amplitude, in a random pattern. And how quickly it does it, that's what the frequency does. Let me explain it like this. Think of a sinus function. You have an x and a y coordinate. The sinus wave, it just goes up and down, and on the x, you go for whatever x value, you have a specific y value, and it always ranges from -1 to +1, like the sinus wave just swings. And for any x value, you will get a y value, which is somewhere between the range of -1 and 1. But it's not random. This is like fixed, so you know exactly that the sinus of 0 is I actually don't know where sinus begins. Is it either 0, -1, or +1? I don't know. But after one rotation, so after plus 3.14 pi, you get the same value again and again and again. Now, the noise is something that is just random. So that means you have still a function that for every x value you feed into it, there is a very specific y value, but not like the sinus wave. It's a random thing, but it still remains between a given range, so like -1 and +1. Now, the 3D noise is essentially 3 times this. The 3D noise is just this in a volumetric space, somewhere in the range of this amplitude. Amplitude means the range from 0 to plus amplitude and minus amplitude. Essentially, what this 3D noise node does can be maybe explained slightly with this volumetric fog, because in this fog, you also have these kind of shapes in there. And this is 3D noise, essentially like the node in FlowGraph. And here we can also change the frequency, and essentially the amplitude here is just from no fog to maximum fog. But if we, for example, change the frequency here from 10 to 50, it's going to make it, let me know, lie probably more detailed. Little more like little.
Or is it inversed?
Is it inversed? Frequency, the higher. Let's put it to 1. Yeah, okay. Now, lower values means bigger structures. So now there's barely any detail, and the higher the value, the more detail there is. And it's similar on the 3D.
So the bigger numbers are giving you smaller clumps?
Exactly. Now back to FlowGraph. So why am I doing this? I wanted to fake wind with this. Essentially, I'm getting the position of the object and use it as seed for this 3D noise. So when you have a random function, it will still give you always the same y coordinate for a given x coordinate. But if you choose a different seed, it will be completely new and completely random. So this is a way to say that every prefab, every light we spawn has a unique position, and therefore it will get a unique noise mapping. Let's assume I would not use this seed, and every prefab, every light would have the same seed. Then from the beginning of the game, every light would move in exactly the same way because they get the same impulse in the end. In this node, it starts to shift from time 0 going forward with random values between the amplitude and with a given frequency.
Of course, the other aspect of this whole setup that really makes it work is nothing to do with FlowGraph, it's physics. It's the use of these two ropes entities that ultimately constrain the movement of the swinging street lamp. Now I'm going to let Alex explain in depth the C++ code that he wrote and how he exposed his components to FlowGraph for Motto to use in the level scripting.
Let's look at the player. So the player was based on the standard player component from the top-down example, and I only modified it slightly because the top-down player was already fairly well written for what we wanted to do in our game jam. So as you can see, it has the default input flags here. It still has all the functions, I think, besides the animation ones, because we didn't need animations for our players. As you can see, we have still initialized. We still have the event flags for processing events throughout the game. We still reflect some members here. So for example, we reflect movement speed, max speed, sort of like all sorts of different variables we need to control the player inside the editor, right? Like we don't want to restart the engine every single time to change a single value. Like for example, if you want to change the movement speed, you can just change it inside the editor, and that's why it's reflected in here. So if we look at the game, we have a player schematic object, right? And this is the editor, right? And in here you can see this is our little guy, and we have a mesh component, we have input components, but we also have our own C++ component, the player component, right? And this player component defines movement speed, max speed, and so on. So all those values, you can set them in here, and the engine will pick it up and use them for whatever you wrote in C++. Those are just reflected variables, so we can adjust them. Then we have some functionality for the player itself, so we can revive the player, which just means he just gets resetted and some of the states of the player get reset. Then we have activate, which just activates the player again, and we have the invincibility, which was just added for debug purpose, so we could just play through the game without dying all the time, because we were kind of short on time, right? So we try to be as smart as possible about our time. We still kept the update movement request and update camera from the original template, which we branched off here, right? If I look at those functions, they still control the camera and they still pretty much update the movement of the player. Then we still have the handle input flag, there's nothing special about it, and we just keep our components in here so we can always use them inside the class. So if we need to update the camera, we just hold the camera component here as a variable, and same goes for all the different states of the player, right? Like we have a delta movement for the Xbox controller, for the keyboard, some Boolean variables if the player is currently sprinting, and so on. So that's pretty much what has been changed in the player. And if we look at the implementation a little bit, we see that in the initialize, we set some specific flags for this entity. So we, for example, tell the entity to trigger areas. So it actually can walk through areas and it will trigger it. And we also set no decal to the entity. So in case there are any decals in the scene, no decal gets projected onto the player. We just get the input controller, we just get the character, and then we start to register all our relevant actions for Xbox and keyboard input. So we just like add the different buttons on the keyboard and Xbox controller to the specific key defines we have inside the class to then later on use it to control the player pretty much. And then the last final relevant part here in the initialize function is that the physical entity should be collision filtered, so the player cannot collide with certain objects or the other way around. So we define a specific type for our physical entity, which is the player here. And we just tell this type, this could be anything. I just used this for some reason. This just needs to be a bit masked, but that's it. So that's totally fine for us here because we know the game's not going to be huge. I can just hard code it here and just remember it in the other class. And then we just tell the entity here to set those params, and then this filtering class or type is registered in the physics system. Then we just tell the entity system to receive some events here, and the rest happens inside the requests we send to the entity system to receive those events, get then processed here. We don't do anything if the player is not active, which makes sense. But in case, for example, we collide with something, so most of the objects in the scene which kill you are just physical objects. I think all of them are just physical objects. So the only logic we really need to check here is if we collided, with what did we collide? And in our specific case, we checked if the object we collide with had a damage component. And the damage component just defines the object to be lethal to the player. So the player will check for a damage component. And if there's a damage component, he just dies. So Matto did logic to set specific anchor positions for the player to get reset when you die, because it's a pain if you die at the last point in the map and you have to do the whole level again.
These 3 flow graph nodes demonstrate how player death is handled. We have an area trigger here, and as soon as the player enters it, this free-floating empty entity that the player doesn't see, which is just called respawn, gets beamed to a checkpoint. And that checkpoint is at the beginning of an area where the player potentially might die, which is the traffic intersections and where the dogs are. Anything with that damage component attached to it. So if you do end up dying trying to cross the street, you're going to get beamed back to the current location of the respawn entity, which gets moved from checkpoint to checkpoint as you try to cross dangerous areas.
And yeah, and on the update, I think we just do pretty much what the template does by default. So we update our movement and we update the camera. This is the movement request update. Oh yeah, one relevant part for this example is that since we move with the camera, so the camera is actually animated, we need to be relative to the camera. So the input needs to be relative to the camera, right? Because the camera could rotate in any direction, and we need to still, when we press D, it should still go to the right from the camera view. So most of the stuff which actually happens here is just some calculations based on the camera and the input. So yeah, the first thing is we just check if our physical entity, which is the player, is too fast or faster than our maximum speed. And if that's the case, we just don't add any force anymore because we know that the player is already going at max speed. And if the player is not going at max speed, we will start to get the velocity of our player, so we know in which direction he's currently heading. We check for some input flags. For example, if we sprint, we just add more strength to the impulse we want to apply to the player. So that's just what happens here. We just check if we actually are allowed to sprint, because you shouldn't keep it pressed and then just sprint forever. So there's a timer. If we are actually allowed to sprint, we just set this variable to a defined value, which we can set up inside the engine. Yeah, we just calculate how strong the controller is actually, like the analog stick is pushing to which direction. So on the keyboard, you just can press a button and it's either on or off. But on the analog stick, you actually can get sort of like a strength in which direction you're pressing. So that's just what we calculate here. And then we just apply it to our already calculated direction and movement speed. So this is just all controlling the movement speed. And now the relevant part comes into play. I mean, I already mentioned that we need to calculate the relative movement direction from the camera. So that's what happens here. So yeah, but this is just calculating sort of the actual coordinate system of the camera and then projecting just the direction of the input from the controller onto that coordinate system of the camera. So we just do some math here and then set up the final impulse we want to add. And of course, add the frame time to be frame independent. And that's pretty much it for the player movement. And the update camera is actually also pretty straightforward. Or actually, the update of the camera is not really relevant here because we update the camera from FlowGraph anyway. So the whole camera up is animated. So I think this is just a relic from before we actually changed the camera to be animated. So this is more or less, I mean, it's nice for testing in case you don't have a camera set up which is animated, so you at least get a camera which is somehow following the player, but this is not really relevant for the game in the state which we released it in. Also interesting in that connection to the player is the player wall, and we needed some sort of way to limit the player where he can go, right? Like, of course we could have actually placed collision objects in the scene, but sometimes we just didn't want to place a house on the street because, well, there shouldn't be a house, right? So you need some sort of like invisible walls. And that's just what this component does. So the whole idea of the component is just to be placed on any physical object or on any object and then tell this object to only collide with the player. So the setup is pretty trivial. So we just gave it some reflected values. We just have a size. And then if you go into the actual implementation on the initialize, the only thing we really do is just tell this physical entity to have a specific collision ordering and ignore type. And that's all. So technically what you can do with this component is you can add it to any physical entity in the scene, and then it will only collide with the player. And as you can see here, this was still some prototyping code I had before, because we weren't sure if we just want to already like also create a physical collider inside this component. You just need the component. But it was easier for us to be able to like build something inside the scene which is more complex and then just add the component instead of like creating here like a box or sphere or whatever. So you see all those like long solid blocks are just the player collider. So if you click on it, you see it has a rigid body, it has a box collider, and it has our player wall. So the player wall just tells this object to ignore every other collision besides the player. So for example, the cars can still, of course, go through here, but the player can't. The next node was a respawn player node. So this node does pretty much exactly the same thing as this one. It just exposes some standard fields for you to be able to like connect the node and so on, and then just calls the revive function of the player to be able to just reset it and then like to restore all the information of the player that he died and now a new turn, or like he was respawned and now we start from a new checkpoint and so on. One relevant part for registering flow nodes as well inside your game DLL or your game plugin is to actually tell the plugin to also listen for registering flow nodes and unregistering them, right? So you just need those two defines or macros inside your C game plugin, and that's it. And then it will automatically pick up the nodes you defined inside this plugin. The actual relevant logic part in your code always happens on a process event. So you will see, okay, if actually the node was activated or initialized or moved around, then you can react to those events inside the activate or whatever event you want to listen to. So for example, let's say if someone calls this node I wrote in C++, it will know, okay, it got actually activated now, and I get the event, and then I can react to it, and I can actually read the information from the ports. And that's pretty much what happens here. So we just get the port entity ID, we get the port bool from our specific ports we set up at the beginning. We get information for the entity, we get information if we want to enable it or disable it. And then we just tell the entity or our component should be activated or not. And at the end, it's very similar to reflecting your components. You need to somehow tell the engine that this thing exists. So we just use this macro, and as you can see, there's like a huge define after it, but this is not really relevant for the user. He just needs to call this macro with the name, so you can define how the node should be named inside the editor and the specific class you want to use for it, right? Which we defined in here.
So that's an inside look at how the Homebound game was put together during Global Game Jam 2019. I hope it gave you a glimpse into what the game development process with CryEngine 5 can look like, and also gave you some ideas for your own games. Up next, the game developers will answer any questions you might have about the process they went through while building this game. And we're back live, folks. This is Brian Dilg again, and now I do have with us live 3 Germans, 1 Frenchman, and myself, an American, all slightly giddy at hearing themselves on video, and prepared to answer your questions. I'm just going to go ahead with the first question that was sent. I'm sure there's things the guys probably want to say, mostly to say, well, we only had 48 hours and we would do things differently if we had more time. So it's something to keep in mind. The question was from Bowser, and he actually asked about the swinging street lamp that Mato put together. And his impression was that it was done not with rope tool. And in fact, it was done with rope tool. Mato, I don't know if you want to talk about that. I showed it in the video, and I can try and find that spot. Or, we should do is actually launch the engine, and we can show it to you in the sandbox. So while that's launching, Mato, I don't know if you want to chat about that.
Yeah, so the swinging light does use ropes, and our default rope setup, like when you place a rope, it will already work out of the box quite good, and it's also fairly cheap. The rope has a million of properties. It has lots of parameters you can change and do all sorts of crazy things with it. So in the end, you might even do ropes that can wrap around things or something like this. But it's a very tough thing to do and to test and to work with. So that's why the ropes are only used for the swinging light. I mean, the real question is why it's not used for the dogs, because the dogs would be like the more obvious choice.
I think I pummeled you with that question.
Yeah, so the dogs use constraints because the problem with ropes is they are really hard to set up in the really right way and make them like not fall apart, or because the dogs are one crucial part of the gameplay element. They might block you, like if one of the dogs' chain clips through an object, and that happens sometimes with a rope, then there is a potential game blocker because the player cannot proceed anymore. That's why for the dogs, I switched to the constraints. It's kind of a more cumbersome setup, but it did work out very well in the end. And I think it even looks almost better for the art we went with. So I just wish I swapped earlier to the constraint setup, because I took quite some time to tweak the rope, and I couldn't get it working. So yeah, in the end, constraints it is.
I think it fit the whole low poly style of the game with what Victor did with the player and the AIs and the dog itself. So it didn't stick out. Bowser also asked, how do we get the basic blockout? How long did it take before they came up with the idea? I'll let you guys address that since I was not here for the actual game jam.
The idea for the game, I think we had like an hour chat where we came up with all sorts of ideas. Yeah. We had good ideas. We put them all on a board, and where I think we decided well with is what the engine can do better. Like the ideas we had, this was the idea where we thought the engine would suit the best with. Like we get out of the box already the volumetric clouds, the rain, the good lighting which we can use for the night setting, and these were kind of given by the idea which we wanted to go for.
I had a question related to that, because Victor, you and Mato worked together to create the city. And the scope of it really surprised me, given that it was 48 hours. Did you know it was going to be this size? Did you have a sense of how much work that was going to be? Because I would have sort of been panicked about getting it done in 48 hours.
Well, I used to work with modules before, so it was more up to how much gameplay we can actually fit into. It's not art related. We could have made twice as long, and it would still need the same amount of assets. We just need buildings and streets. There's not much overhead on the art side in terms of length, but getting gameplay elements. We had ideas about getting on a train and riding around, and we had a lot of ideas. We can extend this game really far, but you just run out of time.
Wait a minute, I don't know who's guilty of this. I shouldn't say guilty. Didn't someone have an idea for like cleaning house game? Was it you, Alex?
No, that was actually Mato. That was the first idea. Right?
Yeah.
So going to be vacuuming involved.
Yeah, no. The idea was like, I mean, what home means to you, and my suggestion was, okay, it's about cleaning and tidying up, or keeping the house clean. And I think everybody can relate to that. And making a game out of it, you have a room or a flat, and there's things in order at the beginning, and then at some point they might just fall apart because of a cat walking through the room, and it just starts to everything falls apart, and you just have to make sure everything is clean and tidy. Maybe vacuum cleaning because there's constantly dust falling on the ground.
Victor's cat running around shedding hair on things, chasing after with the vacuum.
So that was one of the ideas which I thought was really cool. But again, I think the idea we took, we kept on working with is actually it's more cool, I think. Yeah.
I also think it fits the theme better than the cleaning thing, because I saw a lot of games regarding the theme more about like doing something at home, but it's also that like I don't get that feeling what home does mean to you from those games. It's more like, okay, that it's a connection to the home, but here, like especially in the last scene, I really love the atmosphere you get when you like the nice music starts to play and you like the cat greets you and it's like nice and happy.
By the way, did somebody make that music here? Or did Lucas find it somewhere? Lucas Kyle did the audio, but he couldn't be here today. I don't know where the guitar track
It's not made in-house. I think I'm fairly certain it's some stock library.
There are guitars in the Crytek office,
Yeah,
as well as plenty of musicians. So I was just wondering about that.
we have a huge library of like standard sounds we could use for the game, and I'm not sure if he took that from there, but we took a lot of sounds for the game from that library.
There's two new questions here. One was from Rizo. Your question was about, is it possible to make any kind of game with CryEngine? For example, could you make Assassin's Creed? And I'm sure everyone's got opinions about this.
Well, if you have the same resources, you can do it.
Exactly.
More about people than
I mean, technically, of course, you can do any game in CryEngine if you have the manpower, the knowledge, and so on. I mean, it gives you all of the tools, or most of the tools you need, but if you have a really specific gameplay mechanic, and for example, Assassin's Creed back then was the first game to really have this climbing mechanic, right? You need to sort of like implement this very specific gameplay mechanic yourself. So like no engine will ever give you all the super specific gameplay technology right at your hand, but from the technology we have inside, you can already build upon that, right? And I would say it's totally possible. I mean, we have some community projects for RTS, as far as I know, like an RTS and first-person mix-up. We have puzzle game, we have adventure game, there's even a chess game. So it's definitely possible to do sort of any kind of game in CryEngine, but you have to keep the scope in mind.
Okay, another question was from ALBIM75. If you had the chance to use Schematyc 2.0 in your game jam session, which we did, there's a bunch of Schematyc in here, would you still use Flowgraph so heavily? Is there any particular set of features that make Flowgraph still the weapon of choice compared to Schematyc 2.0? Very popular topic.
Well, the schematic that's in 5.5 is still very limited until you have unless you have programmers that expose all sorts of functions for you for specific entity usage. There's not so much you can build with it right now. I mean, like out of the box. But in the future, I mean, I've seen what we have worked on in Crytek, and it's gonna be amazing. I mean, Schematyc will at some point replace Flowgraph.
It's reassuring to hear you say because you are Mr. Flowgraph. I'm very, very excited about it too. In fact, I cannot wait to start teaching people how to use it. But yeah, I don't know what else we should say about that. I mean, I think I said on the video that part of what happened, you got 48 hours, you have a very specific set of people. It's not like you've got a game concept and you kind of find the ideal people to build it or something. You have these particular people with particular backgrounds, ranging from new Crytek people like Jean-Baptiste to people that have lots of experience. And the level designer happened to be Mato, and he's a real Flowgraph specialist. He is a guy that can make anything happen in Flowgraph. But, for instance, components aren't, not exposed to Flowgraph. So we had two programmers on there, so it worked out really well to have them expose those components to Flowgraph. So Mato could do his thing, they could do their thing. I thought that worked really well. Yeah. You wouldn't necessarily do that. And of course, when Schematyc comes out and everything is modular and all entity components are exposed to it, and it's generating C++ under the hood, hopefully that's going to be a radical thing, an amazing thing.
I mean, generally, we want to provide like even a bigger feature set for Schematyc than what Flowgraph offers you right now. So you don't want to go back to Flowgraph. You just want to use the new Schematyc. So that's also definitely the goal we have in mind.
I'm sure we've talked about it in many different forms, but there are subtle timing issues with the way Flowgraph works. I guess we'd call it level scripting rather than sort of entity scripting.
There are no such things as timing issues in Flowgraph. It's all user error.
Of course it is.
No, if you know the underlying code that works behind it and how it executes, it's actually straightforward. It's just nobody, when you work with it, if you don't have the knowledge about it, you don't expect all these like delays and that a flow node takes execution time, and actually you can have things running in parallel, but then if you bring them back together, you get suddenly some weird results. But that's actually just to the or by the design of Flowgraph. If you know this, I mean, then Flowgraph, I don't know, it becomes even more powerful.
We don't have any more questions in the queue. Do you guys, do you want to say anything in your defense or any comments that you want to make? We didn't talk about the AIs.
That's true.
And Alex and I did do some recording on that, and I think I'll probably add it to the video before we publish it, but I don't know if there's anything you want to say about it.
Yeah, I mean, the AI is actually rather interesting implemented. So we use the entity links inside the editor to sort of like set path or waypoints for the AI. So we have a look, like the AI actually moves around when we start the game. And if I enable the helpers here, you can see that those entity links tell the entity where it should go. And you can actually build pretty complex paths with that. So with this system, you can pretty much loop paths that would constantly run in circles or would do whatever you want. It's a really easy system to set up, and you don't need to code much for it, which was like the main point for us, right? We didn't want to spend much time setting up AI characters, like the size of the nav mesh and all that stuff, regenerating the nav mesh when it's necessary. So with this system, it's super quick iteration times, and it's super easy to set up.
Question that hadn't occurred to me before, because we've got a plane constraint on all the AIs in the player, so there's no z-axis movement.
Right.
Does that mean that the linked entities have to be at the pivot?
Actually, no, because I completely ignore it. But I mean, in the code, I make sure that I ignore the z-axis. But in general, it helps to put them on the same line, because otherwise, if you put the entity you link to into the terrain, you won't see the full link, right? So it kind of makes it a little bit obfuscated. But technically, it doesn't need to be like on the same height.
I noticed that thing with the car movement system, because I had made some hilly terrain, and my path that you can see from the link between the target and the spawn point got buried, and then the car refused to go anywhere. Yeah. And
because it's a very simple system and they just go straight forward. So
he's just being humble. He's going to go straight to Google and reinvent the whole world of self-driving cars at last. Straight lines only, very nice brakes.
Yeah, very nice brakes. Yeah, it's all it requires.
But also, I mean, coming back to the anti-links, I mean, we used it for this specific purpose for our AI characters, but you could use this for any logic, like if you have some sort of light source in the scene and you want to have multiple switches in the scene to actually enable that light source, you can also use links. Like, it's a super versatile feature, or like you have a lot of different possibilities with that linking, because you always get the link to that entity, and then you can implement all sorts of logic, right?
Just opening in the schematic for the crowd entity, so you can see that they're quite similar to the player,
yeah, exactly.
But without input component.
Yeah, I mean, this person component, this is my only custom component I wrote in C++, and it's not doing anything like setting mesh or something like that. It just controls the person itself. All the other stuff like physics and the mesh and so happens with the already provided default components from the engine, right? Like the mesh component, the plane constraint component, and the rigid body one. Those are already handling like most of the sort of setup in the engine, and I just need to hook into that and just implement my logic, like moving the player around and so on.
Rizo asked a question about, can CryEngine be used for enterprise? And I'm not sure if you're talking about managing group software development or...
It sounds like a business question.
Yeah.
Yeah, I don't know, Rizo, if you're still there, if you want to clarify your question, if you're talking about a licensing question or about software development. Yeah. If it's licensing, I'd refer you to the EULA to read the terms of service. We can certainly talk about what it's like to develop games in terms of the perforce and that kind of stuff.
The setup in general. I would also recommend to check out the CryEngine webpage, right? Like CryEngine.com, and our Discord channel. Because in Discord, we actually have a dedicated channel for it. In our Discord, we have a dedicated channel for licensing questions, and our team will then check those questions if they don't know it and will answer it.
And a dedicated Discord channel as well. Yeah. New question to the developers here, working in a game jam session in a few days, that's generous, less than 2, plus some sleep. Did you gain any useful lessons to speed up the workflow of CryEngine?
We're already quite experienced developers, and we're using CryEngine for many years already. And I think we already choose the most efficient way of building this. I mean, we use prefabs quite from the beginning on, and then, for example, building the level was something that was way quicker, like it speeded up. I mean, obviously I didn't start right away with prefabs at the beginning, but when I saw, my shapes are actually quite repeating, and I'm anyway cloning certain objects, then I thought, okay, I'm going to swap to prefabs right away because I know in the future speed up things massively. And that exactly was the case. I mean,
yeah. I encourage you guys to pull the game down from the marketplace and pull apart those building prefabs, because Victor did some really amazing stuff and made Mato's job really easy, starting with just having the boxes to represent the buildings. So Mato could work in parallel with him while he modeled the details in 3D Max.
Yeah, that's very true. At the end, when we didn't have much time left, even I started to do some level design, or just placing some objects and doing the dressing. And it actually was so nice to work with all the different tiles and just aligning it to look really nice. So.
Yeah, it's because I spent way too much time on the bar. Modeling the bar was an accident.
But it's a really, really, really nice bar, though.
It's a great scene.
But it was worth it because we used the bar basically as the starting piece for all the other buildings. So all the other windows and doors are just taken from the bar model and then just reused over the whole city and modified a bit.
And I also actually at the end started to design some objects in CryDesigner to have some sort of just props in the scene so it doesn't look too empty. That was also, actually, I was quite impressed that they didn't look too bad for my art skill.
It's not meant to replace Max or Maya, but you can do some amazing things. My colleague Christian, who sits next to me and does tech support, is so fast with CryDesigner. It's just sick because he never touches Max or Maya, I don't think, or not very often.
Yeah, I think those pillars or posts, they're actually made with CryDesigner. Then I think most of the trash cans and those garbage bins are all made with CryDesigner. Even the lantern, I think I just clicked together in CryDesigner. The bus stop, the bench.
You did the bench in CryDesigner?
Of course. I mean, come on.
Seriously. That's
and then I also did this. I tried to have a telephone booth or something.
Because those are so popular these days.
Exactly. But I don't know. It was more for faces. But at the end, I guess you kind of get the idea. And it just put some stuff into the scene.
Okay, so the inevitable question from Sam is, if you were to build this again, maybe I'd say maybe more than 48 hours, what things would you change? This could be a long answer.
Yeah. I mean, in general, from the coding perspective, of course, you would build the stuff in a more generic way. You would set it up much cleaner, more extendable. I have some hard-coded values here and there, it's just I can just use this AI with the linking, right? I mean, this wouldn't work great in a full game, but it worked fairly well for us. I think it's just about the scale, right? You need to know the scale of the game and then adjust to that.
Yeah, for me, I would say one thing we could have done is regarding the car spawner, which is completely random. And I think we could have spent a bit more time letting the designer have more control of the car spawning. Maybe not using a complete random generation, but maybe a Gaussian or something like this.
You mean like a Boolean random on-off thing? Or?
I was referring to a Gaussian random generator, which is so your number will be more centralized and you have more chance to generate a number in the middle of the range than on the outside. So or maybe just offer multiple solution for spawning cars, maybe.
Yeah. For example, we could have also done some sort of waypoint system for the cars, right? That they can actually turn.
Yeah.
Right. But
Bowser asked a question specifically about how they used CryDesigner. Was it fun? Did you make things out of one object by extrusion, edge loops, combining a few others, Booleans, I assume? I don't know if you guys want to talk about your process.
I mean, since I'm a clear expert on this, I should definitely talk about this. But no, I mean, in general, I just used the extrude thing. I'm not an expert on this in any sense. I mean, I know how to use Max and Maya on a really on the surface. But for this, I just extruded the faces where I need them. And then if I needed to do some crazy stuff, I used the Boolean cut to form the object.
And Victor, I don't know if you want to tell us any of your secrets.
Yeah. I think actually Victor.
Well, the street is made with Max, so that's not.
These blocks?
Yeah, these blocks are made with Max.
Okay.
Most of the things are done with Max just to have proper physics proxies.
Yeah, that's very true.
So we just have really optimized physics proxies here. This is something you can't do with CryDesigner. It's just not meant.
Which is funny, given that the player floats over everything. But no, of course it makes perfect sense.
Still, everything has to collide properly, and
we didn't know at the beginning what needs to interact with, like how, in which way, right? We could have done some objects which just roll over the street or whatever, and then it would be really helpful to have a proper physics setup.
Yeah, and also it's just cheaper to on the calculation if you have optimized primitive physics proxies than using the actual geometry to collide with.
If you enable the
Proxies?
Well, look at that. It's not primitive.
Yeah,
it's
as
a
you can
render
see,
mesh.
like
Not even for the
What?
street pieces.
No.
I can
Who
see it.
modeled that trash can?
But the render mesh is only where it has the internet.
yeah, that's true, but that's fine.
I'll do that with proxies.
But as you can
But
see,
I could actually.
but
No
as you-
time.
yeah, as you can see, like the trash can is so expensive, it's crazy. Like it has a lot of, like, of course the collision will be very specific and very like detailed, but for this case it's a trash can. This could be just cylinder or
Yes.
like a sphere or whatever.
And it would be, potentially.
Yeah, but this is definitely something I would do for a proper game. So if you place those trash bins everywhere, they should be optimized, right?
We could make cars with brake lights. I think we all agree that we got robbed by Victor, who is like Mr. Particle Expert, who did no particles whatsoever. There's one particle in the game, which Alex did, which is the crashed car.
Yeah, I just needed to like somehow represent that something happened here. You know, like at that scene where the police comes. I just needed to show that, oh, something's burning here or something happens, right? So you immediately spot this accident.
Yeah, it's definitely, and Alex would agree, there's way too little explosions in this game.
Yeah, I agree. Like,
Nobody really dies.
Yeah, so
Yeah, we definitely. I think your idea about having the cars splash rain, like in the puddles, on the player would be awesome for starters.
yeah, there's a lot of effects like smoke from like sewers or something, rain,
Tailpipes.
everything's like you can add a lot of atmosphere by just adding very simple particles. You don't even need much. I mean, these are just squares, and you already get the feeling of like this could be smoke.
Well, it goes again with the low poly look of the game, though.
Yeah, I mean, I wouldn't change much on this.
yeah.
We would totally do a smoking pedestrian. I think that would be a really cool detail. I mean, for the pedestrians, it was really fun. Once we got the feature, it was really amazing to place them in the level and to populate it, and it suddenly becomes just way more alive.
Yeah.
And we actually had an idea about adding thieves to the game. So it's a similar mechanic like the dogs. So when you get too close to these,
Well, especially, I think you were talking about in the darkest part of the
exactly,
game back here,
exactly.
which is pretty terrifying.
So that's where I thought that would be cool if we had some fishy looking pedestrians, and if you get too close, then you also die.
Man in van.
But then again,
Dark
like
suit.
it was actually not even necessary because we have, for the amount of time the game plays with, we actually have enough gameplay features already.
Yeah, that's true.
It would be too much. I mean, I really like the idea, and if we had a longer level and more time, I think then it would be a really cool feature.
Yeah, we also had the idea of like having, because we already had the AI characters, having like sort of traffic light, and when it switches, all the people run towards you, and you like the need to like
Ooh, that'd be nice.
evade them and like actually get to the street before the light turns red again. Right?
I could see lots of cool possibilities
Yeah.
for kind of giving some intelligence to the behavior of the vehicles and the AIs. Who did the dog model?
Actually, that's not mine. That's not mine.
The dog model, that's me doing it. Yeah, although I wonder if I think it's a scaled box. I think it's not even a designer converted. I'm not sure. Let's have a look, because I really don't remember what I did.
I feel like my models are more detailed than this dog, but I really like the dog actually. Like, I cannot say anything negative about it because it looks so nice with just this box and then the barking.
It's the whole
the way it
behavior.
moves.
Well, I think that he gave it that little up impulse so that it leaps up into the air, which made all the difference. Otherwise, I don't think it would have occurred to me to do that.
So yeah, it's a primitive cube scale, right?
Exactly. So there's no designer involved here.
Nice work.
Design is just
Efficient use here.
Next time you can add some little boxy ears and boxy teeth, wagging tail or non-wagging tail.
Yeah. I'm not sure if we answered the question regarding what would you change from the perspective of you guys, like Victor, because I think we talked about the code part. But
So what I would change is like spend less time on the rope setup for the dog because that just ate a lot of time to figure out that I should do it with constraints. If I would go with constraints right away, I would have had time to, I don't know, like build a better level or a better spaced out part in the level where the dogs create an even better challenge. I mean, the graveyard, for example, with its dogs, it's very little thinking a player needs to do to actually pass the challenge. While there's actually something I could build it way more interesting where you had to, I don't know, lure one dog on around one chain to be actually able to lure another dog around another one. So something that's really like you have to think about how I can get past this. That would be one thing I would change. But more time would be awesome. I mean, again, we had so cool ideas.
Yeah.
But that was a rare experience. I know at least one of you commented on. You just rarely have this. Our games are so big and complex and take years to build. You had to make fast choices, and you developed some interesting stuff.
Oh yeah, I remember like at the beginning, I had placed all those trees and vegetations out of designer objects, and the whole thing was already populated. And then once we got the models, or when actually Victor provided the models, I was like, oh man, why didn't I use prefabs? Because these vegetation pieces were the only things I did not build out of prefabs. All the other things, the houses and the fences were all prefabs to begin with, but the vegetation I really didn't expect that we get the assets as well, and then I had to just delete everything and then replace.
Prefab regret.
Yeah.
Yeah, but I think regarding your question about or let's say it was nice to make the game without thinking too much about it. Like you need to do the fast decisions, especially from coding point. Like if you work in the engine and you code a lot of like modules or features for the engine, you need to think very carefully about what you do, right? Like it needs to scale well, it needs to perform well, it needs to be extendable and all those sort of things. But if you code something for 48 hours, it's like, yeah, I can hack this. There's no problem.
I personally feel like I wish more people would build smaller games with CryEngine more rapidly, because I think there's this vague impression just based on Crytek games that it's only suitable for building these giant, crisis-style games, and you can actually do things really rapidly. That was one of the reasons I wanted to use this as a case study to show that you could accomplish a lot in a really short time. Well, there's this old saying, I don't know if you have it here, that the work expands to fill the time. So when you have a time limit, which of course you always do, it forces you to make choices. And who did the time of day? Who came up with the mood palette?
We had Yakir making storyboards, or like a mood board for the whole playthrough. So we start with warm colors, and then everything gets worse and worse and worse. And we just ran out of time. We couldn't implement this dynamic change in the level anymore. We just had no time to do it, but we had the concept of how we want to do it. And so this mood that we have right now, that's just Motto setting it up, and we just stuck with it, which is not a bad mood. It's really good. We wouldn't change too much on this one. We just would add some color grading and some variation to it.
Yeah, when we started on the project, it was the first thing I did was get night time of day working. And again, like as level designer or mostly system designer using Schematyc, building logics and everything, I know time of day is its own world. I mean, it has so many properties that you need to spend a lot of time in it to build something. But then when you have it, or when you get used to the values and know what they do, you can do really brilliant things. So the first thing, I think the first 1, 2, 3 hours, I just did time of day settings, trying to get the fog right, trying to get the clouds. Actually, so what was the first thing I looked at was how to get the volumetric clouds in. And actually also moving.
I don't know how you did that. Maybe look the way you did, because my clouds don't look that way.
It's really like I know we have the volumetric clouds, so I just turned them on, and then it's all about playing with the values. So here we got volumetric fog, skylight, volumetric clouds. Yeah, I mean
a lot of values.
A lot of values, exactly. Like, and I think these ones are not even the ones that are the important ones. Yeah, we have other properties for the clouds in the level settings, and they are, I think this is it, volumetric clouds. And here we have like horizon height, tile size. So let's change something, because at first I thought we actually go way lower with the clouds. Let's see, this is do something. If I do it, there was somewhere a height change.
No, it's in the environment.
It's exactly, the height was again something which is in here. So cloud altitude. Yep. So let's see if we can get the clouds down. Yeah. So exactly. This is something I thought at first. That's really cool.
Yeah.
Because that would mean we had like, we would have dynamic change of fog. Like at some point you would be in a cloud or something like this. Actually, does it now avoid being in a cloud, or is the cloud not here yet?
I think it clips, like it doesn't.
I think there's one of the values, or maybe it does.
I mean, it definitely is low.
We have a value that says don't come too close to the camera or like fade away.
Is it the environment probe? What is clipping it out of it? No, there it is. I was touching
but
it.
here we have it now. I mean, this is like, we just don't have a. Well, at some point we will get a cloud here, but this would also mean that we might not see our objective in the distance, and that's just important. So that's why we kept the clouds just for the.
I think you guys also, from the hunting, there was a trailer, like I don't know, some time ago, about the time of days from the new Lost in Delta map. It's quite impressive how you can change this whole map just with the time of day, right? It's like it can completely change the atmosphere.
All right, guys, I think we're going to call it a day. It's closing time on a Friday night here. Thank you so much for joining us. We hope it was instructive. We're going to do additional case studies on the other games that were done for Global Game Jam 2019. So we hope that they're going to comprise a really useful set of information. Have a great weekend, and we'll see you all later on.